EIP 7702 is going to be deployed on mainnet very soon and it is currently on testnet. Do you want to know how to implement this type of smart contracts on your dApp? On this video, we are going to discuss about it and I will show you how simple the concept really is. Let's go to the flowchart of why we need EIP 7702 in the first place. Let me explain the flowchart first. What we have here, first an EOA, which is basically you are signing your own account without a smart contract. Then we have an ERC20 contract, and then we have a swap contract where we want to swap our tokens with another token. So that is basically the current situation on Ethereum right now. If you want to ask me why there are two separate contracts, first is ERC20 is a smart contract for the token itself, and the other contract is for swapping your tokens for another tokens that is owned by someone else. So that's why we need two contracts. But there is a requirement for ERC20 that you need to approve first before you send that token into a smart contract that can swap your tokens. You basically have to sign twice. One for the approvals of your token and one more is for a swap. And the swap will not be executed unless you approved your tokens. So that's why I put this condition here, because ERC20 needs approvals for another contract to take your tokens. So is there other way that we can execute both in one go? Apparently there is. The easiest concept that I can show you is we just put a helper function that's supposed to be in this ERC20 because they didn't put that in their contract. So we deploy just one contract with a helper function that can batch all functions together so we can approve and swap at once. So you can ask me what's the problem here. Please ask me what's the problem here.
I have no idea what you're talking about.
Well, in ERC20, there's a rule that the one who is approving their tokens is the address that owns the tokens themselves. Because you cannot approve someone else's tokens just for a common sense. That's why. So, in that sense, if we put another smart contract here, that will be actually the smart contract itself has to own the tokens. So that's the situation where we need to send this ERC20, our ERC20, into this smart contract before batching the transactions, and only then we can call, approve, and swap at once. So the smart contract will do that on our behalf and it will get back the swap tokens into the smart contract. And if you want that into your own address, you have to call the smart contract to get back the tokens that you want into your address. So that is time consuming and consumes some resources on the blockchain. So what's the idea here? Well, what if this contract itself is you? So you don't have to transfer the tokens into this smart contract. How do you do this? First, we are going to eliminate some features here. We don't need this anymore. And actually, we have to just... Alright, that's better. I don't know if that's better, but Now you can see where this is going. We just switch the position of the smart contract and our own address. Voila! We have an address that can execute a smart contract code. So why can we do this? That's because EIP 7702 magic. So I will explain simply why we are able to do this and what is the difference on the payload data that we are sending before we sign that transactions into the blockchain. And the left side we have the usual payload that you are going to send anything into the blockchain. On the right side is actually the new type 4 EIP 7702 transactions. Do you know what's the difference? I will give you 5 seconds to guess. Time's out. Do you know what the answer is? Correct. You can see this red letters here that you are calling your own address. So you change this to your own address. And guess what? There is an authorization list in the payload. Why? You are just going to point that contract and get that code so you can execute on your own address. So how do you get this authorization list? Well, I give you a very simple way to get that. We have a VM library for JavaScript, and it's a library for all Ethereum transactions, just like Ethers.js, just like Web3.js. And there's a function for authorization lists that you just have to use the function here where wallet client dot sign authorization, and you just have to put that account address here and you get that authorization list to put on your payload. That's basically it. Now we return to the flowchart. You place your EOA with the batch contract previously and you just call exactly how you want to call it before this. But you have to point to address to your own account. That's basically it. Now you have abundant transactions and you only have to do it once. Now this is the smart contract on the blockchain explorer where I deployed that exact contract to bundle all the transactions. And the code is very simple with around 45 lines of code where the function is just to execute batch of nested functions. And with that, we can batch several functions at once. For example, I just made this token transfers to myself for just one transaction hash. And it was actually very simple. So we are going to try a lot of these features in the future, but just know the concept is very simple. Goodbye for now. Wait, before you are going to say anything, I'm just going to make it clear because I forgot one thing. This is actually the payload that you are going to send into the blockchain. And the difference is on 3 lines. One is at the type because we are using 0x4 for EIP 7702. And then we have the to address that points to your own account. And then we have the authorization list that we can get from using vm.js and get the output and put it here. And the address of that is the contract code that we want to implement on our address. You bundle this all together and send that to the blockchain, and you get your own EIP 7702 implementation. Congratulations!